So here's the block. So it's been bored out to 86.25 millimeters, 0.25 millimeters larger than factory. It's been decked, which means they resurfaced the top of it, and it's been hot tanked. So they put it in this tank and it cleans all of the dirt and everything off of the outside of it, but it also takes the original paint off of it, so you can see it's a little bit rusty. We're going to paint it a little bit later in the video. So here we are, we're measuring the pistons. So now what I'm doing is I'm double checking the machine shop. In order to do that, I've got to measure each one of the pistons, make sure they're all what they're supposed to be, then measure all of the bores and make sure that we have the proper piston to wall clearance. And that's the clearance in between the piston and the cylinder wall. Also going to check all of the rod bearing and main bearing clearances. Time to install the pistons onto the rods. So we'll use this assembly lube and get everything all lubricated. These are what they call free floating pins. These little clips hold them in. You install it on the piston and the rod, and the pin is actually able to rotate both on the piston and the rod. What's cool about these JE pistons is they're both coated on the top and the sides. The coating on the top helps with temperature, and the one on the side on the skirts helps with cylinder wear. So you have to make sure that the piston is installed on the rod properly. So what I'm doing is I'm looking at where the valve reliefs are on the top of the piston. The intake valve reliefs are a little bit larger than the exhaust ones. Now that everything is blueprinted and we know that the block is good, ready to be assembled, I'm gonna go and paint it. So we'll just tape off all the parts that I don't want painted and get out there with some engine enamel. We're gonna stick with normal black this time. Now it's time to make sure all the gaps in the rings are correct. What happens is, with a slight bore diameter change, it can change the gap in the ring, and we want a very specific gap. So what I'll do is put the ring into the cylinder, square it up in the cylinder by just putting a piston in it, and then use a feeler gauge to see if the gap is the correct width. So these are a little bit narrow, so I'm gonna put them in the ring grinder and actually grind the end of the ring. So when it grinds the end of the ring, it's taking some of the material off. And when you do that, you just have to make sure that you don't have any burrs or anything on the edges that could potentially scrape the cylinder wall or not allow the ring to seat properly. Once the rings are all gapped, it's time to install them onto the pistons. The first one is the oil spring. So that is like a spring that pushes out the oil rings. The next is the second ring. This one is usually a cast material that's a little bit more brittle. So I'll install that a little bit differently by expanding it instead of twisting it. The cast rings don't like to be twisted and can actually crack. The top ring can be twisted on. There's also little letters on these specific rings that show which is up, and these have a little N on them. So I'll go ahead and twist that on and then do it to the rest of the other 6 pistons. I also like to number all of my pistons and which direction they're going to be installed into the block. I really like to double and triple check everything in an engine. Now the pistons and rods are ready to go in, so I'm going to flip the engine over and put the crankshaft in. We've already checked all of the main bearing clearances and make sure everything's super clean, and we'll go ahead and install all of the bearings. Next, before we put the crankshaft in, we're going to put the oil squirters in. Pretty straightforward. They just bolt right in. These are really good because they help to cool the piston. They also lubricate the piston pin and the cylinder walls. These are called the thrust bearings. Basically, when you push on your clutch to disengage it, it pushes up on this bearing right here. The thrust bearings, I'm actually going to lube both sides of it. That way it's really tacky and sticks into the block and doesn't want to fall out when I go to put the crankshaft in. So very carefully go ahead and set the crankshaft in. This is just a factory 2JZ crankshaft. They're forged, they're really good, they're quite strong, and very common. People will make 1,000 horsepower on these stock cranks. Go ahead and put assembly lube on all of the main cap bearings, and these are all numbered 1 through 7, and they also have an arrow for which goes forward on the engine. Forward on the engine is where the pulley is and all the drive belts, so all of the arrows point towards the crankshaft snout and where all the pulleys would go. So I'll go ahead and zap all those in with the gun. And then I'm going to torque them up to the 33 foot-pounds that the factory recommends. And then they also say do an additional 90 degrees. So what I'll do is draw a line at 12 o'clock and I'll turn everything 90 degrees, basically to 3 o'clock, and that'll get us right into spec. And then once everything's bolted in, I like to make sure that everything turns freely and there's no issues there. So now it's time to install the pistons. The cylinder walls are all nice and clean at first, and then we're going to put the piston ring loop on them. I'm also going to put some of this piston ring lube on the skirts of the pistons and the rings. Next, I'm going to align all of the piston rings because the gaps need to go in specific angles. And again, this is going to vary depending on the engine manufacturer and even the engine builder on how they like to do it. I always like to hold the piston with the exhaust valves pointing towards me, and that way it can be consistent on each one of the pistons when I align the rings. So this is the piston installation tool, and I'm also going to lubricate that as well because the rings have to slide down it. I'll double check the ring alignment again, and now we're ready to put it in. The crankshaft is at bottom dead center, which means the crankshaft pin or journal is all the way at the bottom. That gives you the most room to make sure you don't push the rod into the main journal. So these rods are from BC, and it's their standard H-beam rod, which is going to work great for our application. And they had them in stock, which is great because this is such a short time between the time that we got the engine to the build. We really wanted to use parts that were in stock and not have to custom order. So we'll go ahead and install the rest of the pistons, and we'll be done with this part of it. So once I install the piston, they should be pretty consistent as far as the tension it takes to push them down. If for some reason they're a little bit different, that could be a sign of an issue. And then also make sure that you look at the cylinder walls and make sure there's no scoring or anything that happened on the installation, because that'll show that maybe you had an issue with your ring gap or something like that. So now turn the crankshaft and make sure everything spins smoothly. Next, it's time for the cylinder head. The cylinder head was done by our buddy Tom at Portflow. He took the dirty head, hot tanked it, cleaned it way up. He did what they call like a pocket port or like a bowl port, and it's the area where the valve seat meets the casting in the head. And a lot of the time, the factories don't do a very good job of matching it and having a good flow in that section. And doing a full port and polish, I don't believe is necessary on these heads for the power levels that we're going to be making. This is what they call a CNC valve cutting machine. You can actually program in how you want the valve seat cut, and then it goes in there and cuts it all perfect. Tom then resurfaced the cylinder head and got it all ready for installation. Here's a quick picture of, you can see the pocket port, and you can see where the valve seat meets the inside casting is nice and smooth, and that's where he ported it. Here's all of our SuperTech stuff. So this is the valve train that we're going to install into the cylinder head. Dual valve springs, titanium retainers, CNC keepers, Inconel exhaust valves, and stainless steel intakes. Tom will go ahead and put some grease on the valves. When he installs them, we'll then install the spring base, the locator. The locator keeps the spring centered within the spring locator keeps the spring centered. The dual valve spring is then installed. And down in there, you can even see the valve seal. So the valve stem seal is what stops the oil in the cylinder head from going down the shaft of the valve, the stem of the valve, and into the cylinders or into the port. This is what they call a valve spring compressor. So the valve spring compressor reaches around, it pushes on the bottom of the valve and the top of the valve spring retainer. Once it compresses it, you can go ahead and put the keepers on. Once the keepers are both installed, you can remove the spring compressor, and now the valve spring and everything is all installed. Now we're going to install the dowels into the block. This is what aligns the cylinder head onto the block and keeps the gasket and everything in line. I don't like to hammer directly onto the dowel because it can bend it. So I made this little tool out of it's just a bolt and a nut that stays on the dowel, and then I can hammer the bolt. That way it doesn't mushroom the dowel pin at all. So here's the head gasket. It's actually a factory Toyota MLS gasket. It's called a multi-layer steel. And these are really good gaskets from the factory. So we're going to go ahead and just get a brand new one and use it in this build. Next, we're going to put the cylinder head on. And one of the things that's funky about assembling these 2J engines is you actually can't put these washers on the head with the head studs installed. So you have to put the washers in first, then you put the head studs on, then you can put the nuts and everything in. So I've pre-lubricated the washers and the head studs, and then once we put the nuts on, we're ready to tighten and get our big torque wrench, because we have to torque this up to 85 foot-pounds, and I'll do it in a couple of stages here. So I'll start by doing 30 foot-pounds, then go up to 60, then 85 foot-pounds. These are BC 264 degree cams, and it's a relatively mild cam, and for this drift car, this is probably the best one for it. Little pro tip here. If you grease the inside of your cam seals, front and rear main seals, they tend to seal up and last a little bit longer, in my experience. I'll then put all the cam caps on and install the cam seals. There's a little bit of silicone you see there that goes under that cam cap. I'll just zap these bolts in a little bit. You have to be super careful when you install the cam caps, because if you don't have the cams in the right orientation and you start tightening the cam caps in the wrong order, you can actually break a cam. So you have to be really careful and follow the instructions on the order to put the cam caps in. Then we'll go ahead and torque all of the cam caps. Now I've got our cams installed. Next, we're going to put the oil pump on. There's just some silicone and a couple of O-rings. I've already changed the front main seal. This is our new rear main seal. There's some silicone on that as well. I'll have to reach in, which is kind of a pain, and get these 6 bolts. Next, we're going to put on the upper oil pan. So this one's really cool because it ties in the whole block, and it's actually a bit of a stiffener for it as well. There's no gaskets down here, just silicone. So put the silicone in, zap in all the bolts, and then torque it down to Toyota's recommendation. So this is what they call an oil baffle, and it helps to separate the spinning crankshaft from the oil that's in the pan. This is the oil strainer or the oil pickup. This is where the oil gets picked up from inside the oil pan and sucked through and into the oil pump. So now you can see the stuff that goes on inside of your oil pan. So if you ever have an oil pan that you hit something like something on the road and it dented up, it can hit the bottom of this oil strainer, and that's how you can have a problem with your engine after, because strainer can't actually pick up the oil from the pan anymore. This is the oil level sensor. It's got a little float there, and it just throws a warning light on if the oil level gets too low. This is where I tend to be a lot more generous with the silicone, is on the steel pans. I want to make sure that these suckers don't leak, so I'll put a little bit extra silicone, and then we'll put all the bolts in and then torque it. And you'll see I'm using the torque wrench a lot here, and the reason is it's so easy to over tighten something. Even after years of experience, I believe that using the torque wrench doesn't take that much more time, and you can get everything torqued perfect And once it's torqued perfect, then you can be confident that it's not going to fall out. We'll go ahead and put the exhaust cam gear on, torque that on, and this is the intake cam gear. This is where the variable cam timing works. And inside of that gear, there's some mechanics that, depending on the amount of oil pressure from the solenoid, it'll actually adjust the cam timing on the intake. We really do want this. They can help as much as like 60 or 80 foot-pounds of torque at low RPM. And for a drifting car where you can be at low RPM a lot, the VVTi engines are quite good for that application. If you're doing drag racing or something where you're really spending all your time over 5,000 or 6,000 RPM, where the VVTi is pretty much back to zero, it's not going to be much of a benefit, if any. A little bit of blue Loctite. We'll install the tensioner pulley, again torquing it on, and now we're going to install the timing belt. And the timing belt has a very specific alignment. So on the lower gear, there's an alignment mark on the gear, and then also on each one of the cam gears. So we'll align each one of those, and then we can put the timing belt on. Last, we're going to put the timing tensioner in. Next, we're going to install the timing belt tensioner. What it does is actually puts tension on the timing belt. And before I pull the pin and actually put tension on the belt, I'm going to turn it 2 revolutions and make sure that everything is still lined up properly. And once I know it's all lined up perfect, I'll pull the pin and allow the tensioner to tension the belt. I'll then turn it again and triple check that the belt is aligned properly. Once I know it's all perfect, we're going to move on to the next step. So this is the oiling for the variable cam. This pulls oil from the block down there, and it goes up into that cam cap. And from the cam cap, it goes into the variable cam solenoid. The way the variable cam works is the computer sends out power to this little solenoid, which then duty cycles a certain amount of oil into that cam gear. And depending on that duty cycle, it can actually change the location of that cam gear relative to the cam. And by doing so, it can change the location of the cam relative to the crankshaft, essentially changing the cam timing. Next, we'll put on the valve covers. I've had these powder coated wrinkle red. And for years, I thought it was originated by Honda on the Type R engines. And then recently, I've realized that that's absolutely not the case. Ferrari's been doing wrinkle red valve covers since the 50s. And it turns out that Testarossa actually means redhead. And Ferrari has wrinkle red valve covers for 50, 60 years now. And everybody's been, I think, biting them. So I've added a little bit of silicone on the corners of the cam caps. And this is an area where the oil can often leak. So a little bit of silicone there can make sure that you don't have a leak in that section. You can also see where we added the AN fittings to the valve covers for the crankcase breathing system. We're actually going to utilize both of the NOx sensors on the engine. And this is another area you have to watch out for. So I've masked off that area when I painted the block because I want to make sure that the NOx sensor is directly on the actual metal block, and making sure that we torque it, because depending on the torque, the NOx sensor will actually output a different strength signal. Next, we've got the cam sync sensor. So this sensor tells the computer where that intake cam is in relation to the crankshaft. So now we're putting the timing covers on. It's a bit hacked up to fit the different water port that we've got on here. This car, instead of having a normal mechanical driven water pump, it's got an electric water pump, and it's got dash 20 fittings for both of the lines. Here's the crank damper. So I'll go ahead and put some anti-seize on the inside of the crank pulley and then install it onto the crankshaft snout. And it didn't quite just push on that easy. And look, you can use the pulley bolt to push on your crank pulley, but only if it's really easy to go on. Like this is super easy and didn't have much resistance at all. But if you do have some resistance, you'll want to use a specific installation tool, because if you put too much force on this pulley bolt, you can mess up the threads inside the crank, and you're going to have a real bad day if you mess up the threads. The torque on this pulley bolt is actually 239 foot-pounds. It's really crazy high. It pretty much maxes out the torque wrench. In order to get that much torque, I've got to lock the crank from turning. So what I've done is I've put a couple of flywheel bolts into the back of the crankshaft and wedged a pry bar in there so the crankshaft can't turn.